Hi, Assalamualaikum warahmatullahi wabarakatuh. So let's look at another example related to the application of vectors. So here a ship travels 175 miles at 52 degrees and then 295 miles at 141 degrees and then 225 miles due west. So find the displacement. So the displacement is the net distance between the starting point and the end point and the angle. Okay, so net distance between the starting point and the end point and the angle. So displacement is a vector. It has a magnitude and direction. Okay. All right. Okay, so we are going to start by sketching the diagram of this example here. Okay, so it begins its travel 175 miles at 52 degrees. So if I consider this simple diagram here, so 52 degrees is about in this direction, so 52 degrees, so it is 52 degrees. So the ship travels along this angle of 52 degrees for 175 miles. Okay, next what we can do next is we can continue with the second part of its journey, which is at this point it's going at 141 degrees. So somewhere here, sorry, it's somewhere like this. So this is 141 degrees and it is going for another 295 miles, so it's going a bit longer, so 295 miles. And then we have another part of the journey, which is at 225 miles due west. So this is another direction, but the direction is due west, so we're just going in this direction for another 225 miles. So the question is asking you to find the displacement. Find the displacement. So displacement is this one, okay, from the initial point to the terminal point. So it starts from this point and this is the terminal point. So displacement is a vector. It has direction. The direction is in this way. This is the right direction, and it also has magnitude. So we're going to find what's the distance of that. Okay, right, so now in order to do all this, we are going to consider each part of the journey separately. So first we are going to start with this part of the journey. We're going to find what is the vector of this. So we can call this part as A. So we're going to find what is vector A. Okay, so now vector A is in this direction. So this is vector A, and the magnitude of this is 175, and we can consider the component of vector A into x component and y component. So this is the x component in this direction and y component is in this direction. So this is x and this is y. We can call this xa and ya, and the angle it makes is 52 degrees. So based on that, I can say that xa over 175 must be equal to cos 52 degrees. Therefore xa is 175 times cos 52 degrees. So the answer here for xa, so xa will be equal to about 107.74. okay, next let's talk about ya. So ya over 175. So in the same manner, ya over 175 is sine 52 degrees. So therefore ya is equal to 175 times with sine 52 degrees, and this is equal to about 137.90. So that is the answer that you will get. So therefore we can say that vector A is equal to, so this is the x component, the x component is going in this direction, so it is a positive value, which is 107.74, and the y component, y is going upward, so the component here is also positive, which is 137.90. So that is the first vector here. Next, we are going to look at the second part of the journey, which is going in this direction. So this is this direction here, and we are going to call this as vector B. The component here, the magnitude here is 295. So this is 295, and we can find the component of this vector. So this is the x component going in this direction, and the y component is going in this direction. So this is xb and yb, and the angle that it makes here is 180 minus 141 degrees. So the angle here is 39 degrees. So this is 39 degrees, and based on this we can then construct the same equation here. We can say that xb over 295 is equal to cos 39 degrees, and therefore xb is 295 times cos 39 degrees, and the answer that you will have here is 229.26. Okay, then next, you in the same manner you can find what is yb. So yb here over 295, yb over 295 is equal to sine 39 degrees. Therefore yb is 295 times sine 39 degrees, and the answer for the y component is 185.65. Okay, so we can express a vector b as equal to vector b here is equal to vector b here is equal to, so this one it is going to be negative value because it's going in this direction. This is the left direction, so we're going to write down negative 229.26, and the y component, it is going upward, so it is still positive, so we're going to write down 185.65, so it is still positive. Okay, next, let me just erase some part of this slide here. Okay, next we are going to consider the third part of the journey, which is this one, and this is I'm going to call this vector as vector C. So this vector here is straightforward because it only has the horizontal component, and since it is going in this direction, therefore vector C can be expressed as negative. So this is in this direction, so negative 2 to 5, and the component of y is 0 because it's just going straight to the west, so it only has the x component, and the y component here is 0 straight away. So now once you have managed to get vector a, b and c, you can find this vector here, which is the distance vector. The displacement is a vector. So displacement vector is just adding up vector a, b and c accordingly. So I'm going to write down. So displacement is a vector, and it can be found by adding up vector a plus b plus vector c. So you can add up the component accordingly. So we can talk about the first component. So first component, you add up this and this and this. So the result of 107.74 plus negative 229.26 plus negative 225, and the answer that you will get is negative 346.52. So that is the first component, the x component of displacement. So this is the vector you're talking about, displacement vector. Next, for component y, you can go on and add up this component, 137.9, 185.65 plus 0, and the answer that you will get is 323.55. So this is the component of the x component and the y component of displacement. So displacement here is a vector. So since it is a vector, it has magnitude, so direction is in this direction, and to be specific, we can find the direction based on finding the angle later on. But first of all, let's find the magnitude, the net distance. Okay, so magnitude of that is very easy. You can obtain the magnitude here by taking the square root of negative 346.52, you square it, plus 323.55, and you square it, and you'll be able to get the answer as about 474.09, and the unit is in miles. Okay, so that's the net distance between the starting point to the end point here. Okay, so next we are going to find the angle. So now we move on to find the angle. So angle also tells the direction, exactly what's the direction of this vector. So now the angle can be obtained by considering this. So this is the x component, this is the y component. So basically this is the vector of displacement, and the x component here is negative 346. You don't need to write down the negative sign. Okay, so negative is just for direction. So now this is 346.52, and this one is 323.55. Therefore you can determine what's the angle here by using the Pythagoras theorem, which is tangent theta is equal to 323.55 over 346.52, and the answer that you will get here is going to be, let me just, 323.55 over 346.52. The answer is about 0.9337, and therefore the theta is just the inverse tangent of it. So this is theta, inverse tangent of 0.9337. So theta is just equal to about 43.04 degrees. So that is or we can say approximately 43 degrees. Okay, you can simplify that to 43 degrees. Now oops, okay, sorry, I've just erased everything. Now okay, let me just write down the answer that we've got so far. So this is the displacement vector, and this is the component here, the the x component and the y component, x and y, and we have shown that the angle here is about 43 degrees. But we need to follow, when you write down the final answer for the angle, we need to follow the idea of convention. You need to follow the convention of writing it in this manner. So you have seen that when you talk about the ship that travels 175 miles at 52 degrees, 52 degrees is measured from this point to this, so this is 52 degrees. We're talking about this this part of a travel, which is 175 miles. Next, when you talk about 141 miles, it is measured in this manner, so 141 miles. And then you talk about 22 miles, so this is due west, so this is measured in this angle as such. Therefore, when you talk about 43 degrees here, you must also follow the same convention, where this is the point of reference, and so you must find the angle from this point to this. So based on that, you know that the final answer, which is your angle, should be equal to 180 degrees minus 43 degrees, and therefore this is about 137 degrees. Okay, so therefore what we can say is we can write down all the answers that we have so far. So we have displacement vector is equal to negative 346.52 and 3 to 3.55 with the magnitude of 474.09 miles, and the angle is 137 degrees. Okay, all right, that's all for now. Thank you very much for watching, and I'll see you in the next video.